Okay, so I'm Kevin Mitchell, and it's really a pleasure to be here. And thanks very much to Mike and Adam and everyone else for the invitation. So I'm going to follow on from some of the themes that Anil was talking about and explore the evolution of selfhood and agency and control. So I have a book that I just wrote that's coming out in a few weeks, actually, called Free Agents, about how evolution gave us free will. And it starts with that age-old problem of free will in humans. And it looks at some challenges to free will that I think actually extend much more broadly. So they sort of have various levels. They often get confused with each other. I think it's important to distinguish them because they really refer to different things. At a kind of a high level, there's what I call biological fatalism, which is just that our behavior, our behavioral patterns are in some way determined by the way our brains are configured. So which is a consequence of things that we didn't choose ourselves, like our genetics, all of past human evolution, all of the experiences that have happened to us, and so on, that gives us our biological constitution at any moment that dictates, under this challenge, what we're going to do. There's a deeper kind of a problem, which is to say that, look, all of that worry about your psychology dictating what you're going to do is just, that's all just epiphenomenal. Really, it's actually just your brain is doing it. It's not you doing it. It doesn't matter what you believe or desire or intend. It's just neural circuits firing. So there's a sort of a causal reductionism, which goes down. And then there's a question of how far you go down. Why stop at brains or circuits? And then if you keep going down, you end up at physical rock bottom with quantum fields or whatever the lowest sort of entities of the physical universe are taken to be in our current understanding. And this problem that they seem to be extremely deterministic, maybe completely deterministic. That is, what's going to happen is always what was always going to happen, and there's no choice and there's no possibility whatsoever. Those seem like fairly problematic issues for thinking that we are actually in charge of doing anything. But, and when you ask that question, do we have free will? People usually look at the question of what free means and what will means. I think it's also really important to ask the question what we means. What is the self that could be having free will? And that gets to some of these questions of what the self actually entails. Now, when you start to dig into those problems of what are taken to be problems for human free will, you realize pretty quickly they're actually problems for any agency at all to exist in the universe. How could any organism be said to be doing anything if all of the physics is just playing out, if all the atoms are just going to do what they're going to do, or if it's neurons or biochemistry or whatever is so configured that it actually has no choice or really control. So you can think about the physical predeterminism, you can think about the causal reductionism, and there's two ways to think about that. One is you can just go down levels and say it's neurons or cells or molecules. Another way, which gets confused and conflated with that, is a causation by parts, where you say, okay, it's actually just this bit of the organism that's making the whole thing do something. So it's not the organism as a whole that's acting, it's being driven by something inside it. And those are stern sort of challenges. And what I do in the book, and I'm only going to sketch the arguments here, is look at the sort of metaphysical problems. How can physical systems exercise causation in the world? How can it be a locus of causation? And some of the implications for free will and so on. But rather than just having that argument or thinking about those things in the abstract, actually ground that and say, well, let's not just ask in principle, how could it be? Let's assume for the moment that it did happen, that evolution did give us agency and free will, and then ask, well, what were the steps that led to that, and what are the components of that? So an attempt to naturalize that and get away from the sort of spookiness that Anil was talking about. A very brief overview of the evolutionary pathway that I look at, and this is just the evolutionary pathway along the lineage that leads to humans, not, there may be other types of agency along other kinds of pathways. But it starts really with the origin of life, because I think we have to go there to understand some of the basic ideas of living things persisting and trying to persist, and then the origins of purpose and meaning and value that come out of that, some normativity relative to those goals. you get with multicellularity and the invention of muscles and neurons, much more complex, sophisticated, elaborated kinds of control systems that are informed by perception and learning of individual organisms. And then you get some kind of further expansion as animals moved onto land. They develop vision and hearing, long-term, long-distance senses, which mean long-term planning becomes useful, important, essential, really. And then you get internalized representations that link to knowledge and eventually metacognition and introspection in humans, where the objects of cognition are elements of cognition themselves, where we can think about beliefs and desires, not just the objects of those things. Okay, so that's the whistle-stop overview of the evolutionary story, and it touches on a lot of metaphysical questions that I think are relevant for the discussions here, which include the nature of causation and the self and of time, and indeed the nature of self-causation through time, which I think is actually essential to understanding what it is to being a self. Is that continuity through time and persistence. And then there are issues of substrate dependence, which I think will be kind of obvious as I come through, but we can talk about them more at the end. So last year, my student Henry Potter and I published a paper which is about agent causation. And in the philosophical literature, there's an area called agent causation, and it's presumed to be shown to be impossible. That was sort of I think the philosophical consensus, if you can say there ever is such a thing, that this had been shown to be so problematic that it was a nonsense and we shouldn't really think about it anymore, which I think is a nonsense. But what we tried to do was say, well, what are the challenges to agent causation and what are the criteria that would warrant saying that something really is caused by an agent, or an agent really has causal power in the universe in and of itself at a holistic level. And I referred to them, these two sorts of reductionism already. Vertical reductionism is just going down scales of reality. And horizontal reductionism is the idea that some parts of the organism control its behavior. And then external determinism is sort of obvious, I think, that the organism is just being pushed around by things in the environment. So the vertical reductionism relates to this philosophical principle of causal exclusion, which was advanced by Jae-Gwon Kim and others, where the idea is you may have some levels of reality where, for example, we have a neural system that's composed of cells, that's composed of atoms, and if we want to explain what's happening at the level of the neural system, if it's basically complete, we get a complete description of the causality by describing the molecules and the atoms, then the fact that there are neural circuits doing things doesn't add anything. And similarly, the fact that there are those neural circuits convey things like psychological or cognitive states doesn't do any causal work, because there's no room for it to do any causal work. All the causality has already been explained at the lowest levels. And that kind of leads to a feeling, I think, that's prominent enough in neuroscience. This is a quote from Francis Crick that describes it. The idea that these cognitive states and beliefs and so on are really epiphenomena. They're no more than these neural states. It's not just that they're instantiated in neural states, they're nothing but that. And that doesn't leave any causal power for the content of those cognitive or mental states to have any causal influence in the system beyond the fact that they're just some neural circuit firing. That is a problem, because it suggests that rather than neuroscience explaining psychology, it's explaining it away. Right? We can just say that all of these things are really no more than the neural activity patterns and the computations that are going on in the circuits. And of course, when you start to go down this path, there's no real principled level at which to stop, except the bottom. Right? So why not go all the way down to physics? And we don't know what the bottom is. Maybe it's quantum fields, maybe it's strings, maybe it's superstrings, who knows? The physicist Sean Carroll interestingly describes these lowest levels, which are accounted for by the standard model of quantum physics, as being causally comprehensive. So he said they'll give predictions of what the world is like at the level at which we experience it, that don't allow for any scope for any other kinds of causes except for the ones at the bottom. Now, as it happens, the lowest level causes include some indeterminacy. So physical predeterminism doesn't seem to be true. It's not the case that the state of the universe at any moment entails all of its future states, because there's some randomness. But you can still say, okay, fine, there's some randomness at the lower levels, but that's still where the causation happens, right? And there's a way out of that problem, which is to realize that that randomness at the lowest levels gives some causal slack, some underdetermination by the current low-level physical state that enables macroscopic causation to be at play in the system, without that being spooky or magical in any way. The horizontal reductionism, is a little trickier in one sense, because you're not going down levels. You're admitting that there are functionalities at certain, higher levels. But what you're saying is that the reason why an organism did X or Y was because certain parts of it were active. Right? So some biochemical pathway was active, some neural circuits were firing, or even at a psychological level, some beliefs were held, some desires were held. And that's what's pushing things around at specific internal states. And so in the philosophical literature, that's referred to as event causation as opposed to agent causation, where an organism, a human being usually, is doing something because they had a belief and a desire, and that's what caused them to execute whatever action they did. But it's decomposed to these isolatable states. It's not holistic. The organism isn't doing it. It's just the place where things are happening. And of course, you can do both horizontal and vertical reduction at the same time. You can say, okay, it's these neural circuits, but really it's the molecules within these neural circuits and so on. And then finally, this external determinism is that the organism is caused to do things by external forces acting on it. And it's just a big part of the web of physical causation in the world. Now, you can combine this with the horizontal reductionism if you want, where you say there's something out in the world that the organism perceived, and in a reflexive stimulus response kind of a way, that, through information internal to the organism, caused the organism to do something, as opposed to the organism deciding to do something. So it's being pushed around by things in the world via parts of itself. So we set out some criteria for what we think would justify agent causation. Some of these are criteria that are properties of the agent themselves. Some of them are properties of the universe, like low-level physical indeterminacy. And in this paper, we sort of argued that actually living organisms meet these criteria, and that agent causation is perfectly plausible and naturalizable without any appeal to magic or violation of physics in any way. So the first of these will be very familiar, I think, just the idea going back to Schrodinger and probably much before that, that life, what it really is some improbable pattern of matter. And in this case, a dynamical pattern of matter, not just a state, but that persists in the way that a rock persists, for example, but a dynamical set of processes that sustain and organize and persist through time. So they're obviously, in a tautological sense, selected for persistence based on the simple fact that things that persist well tend to persist. Right? So obviously, the organizations that we see are the ones that were successful at persisting. And that's prior to any kind of evolution using genetic material or anything. It's just a property of physical systems generally. So, but what that gives, as you'll know, is the sense of normativity, right? A locus of normativity. Things matter to the organism because they're either favor or disfavor its persistence through time. So as it happens on Earth, life is comprised of chemistry. So it's sets of chemical reactions. And we tend to think of these, these autocatalytic sets, for example, that, we got different chemicals and they're reacting in various ways. And that whole system is keeping itself going. It's regenerating the constraints that maintain that pattern in the classic sort of framework of autopoiesis. Now, one of the things that's interesting here is, I think, well, first of all, this is a very different kind of stability from a stasis. It's stability through flux, right? It's only through flux that the thing as a pattern persists through time, but it does persist through time. And I don't think that's illusory. Just because it's persisting through flux, I don't think that makes it any less of a self through time. That's just the nature selfhood in this kind of a system. The other thing that is it's a set of processes. It's not a bunch of stuff. You know, we tend to look at these pictures and go, oh, we focus on the A and the B and the C and so on. It's the arrows that make up the stuff, right? That make up the entity. It's not the elements. So you could think about that with respect to this issue of substrate independence. What kind of a system could we build artificially, could be built, that would have that sort of a property to it? So the other properties here that we see are, first of all, endogenous activity, right? This thing is always doing stuff, regardless of what's in the environment. That's how it stays alive. And the other is this holistic integration. All of the parts are in the service of the whole, and the whole thing is constraining all the parts to keep everything going. So it's regenerating its own constraints. I'm going to skip over some of the chemistry. So under those circumstances, of course, an organism, if it is to persist in a dynamic and changeable environment, it has to be able to react to the environment. So it has to be able to know what's out there and to be able to do something about it. Of course, the barrier that it has there insulates it causally from many things in the environment, both physically and chemically. However, it has access to things in the world by these sensors on its surface. And if things in the world change, one of the things it can do is reconfigure its own metabolic pathways. So if there's a different food source or there's no oxygen or whatever, so you need some internal action to reconfigure itself to keep going. But the other kind of a thing it can do is to move. So we can think of behavior as a form of homeostasis, right? So it's trying to keep itself going. It has some information, and then there are some actions that it can do. So it has some repertoire of actions, and it can say move towards things or move away from things. So those things in the world now have value relative to this goal of persisting. And it's just an as-if goal. It doesn't know about it, right? A simple bacterium, for example, but it has causal functionality in the system. And there's some meaning in the system. It's not just information is neutral. It's meaningful in the sense of this pragmatic linkage here in simplest systems to a behavior, approach or avoid. Now, you might think that sounds very reflexive, and there are ways to think about that, but really that origin of meaning, I think, is really key. That gets us off the ground for evolution to elaborate on that to get to the level that we're talking about. So this comes from work of Alicia Huerero and Terence Deacon and others. The idea that the signals mean something for the organism in the sense that they're physically correlated with something out in the outside world, and that's just a formalized sense of relative information, but they also have value to it that's given through feedback from natural selection. So the meaning in this system, it's not that the creatures, these single-celled creatures, apprehend something is out in the world and then decide what to do about it. And then the meaning is in the signal. The meaning is in the response and what natural selection has thought about it in the past. So it's spread through time and it's spread through the whole system. It's not inherent or localized in the signal itself, but it's still exactly what organisms need to get around in the world. It's a real thing, even though it's not quantifiable and localizable temporally or spatially in the way that information tends to be. Now, in this case, it's not semantic. The system doesn't yet understand anything. It doesn't really apprehend anything. It's just pragmatically set up to respond in adaptive ways. But it gets us off the ground. So quickly, in terms of bacteria, they will, you probably know, can move around. They can move in two ways. They can either tumble around in a random sort of in a circle, or they can set off in some direction. When they're setting off in some direction, if they're following, for example, a gradient of like a food source, they will do this type of movement more than this type, and that depends on the direction of rotation of their flagellum. So there's a simplistic way of looking at this chemotaxis of bacteria, where they have a receptor X for some, say, a sugar out in the world, that goes through some protein signaling components inside it that eventually impinge on the flagellum and determine whether it's going clockwise or anti-clockwise, and how much time it spends doing those things. It looks really reductive. It looks really mechanistic, passive, like a stimulus response kind of a thing. And of course, if you isolate it in the lab, and that's the only thing, you control everything else, and that's the only thing it's doing, it will look like that. but nature doesn't present itself that way. That's not the problem that the organism has evolved to solve. The problem it's evolved to solve is this big complex world where there's lots of signals out there, some things it should approach, some things it should avoid. There's all things like, how many other cells are around, what's the temperature, what's the osmolarity, all of those things will affect its response, as well as its recent history. What was the level of this chemical a few minutes ago or a few seconds ago, because that's going to tell me if I'm going up the gradient or down the gradient. Okay? So that's a holistic kind of response. You can't really genuinely pull apart all of those elements and say it's just this pathway that's doing it, because the conditionality is non-decomposable. There's just too many sort of contextual interactions there. So really that's an endogenously active information accommodating model as opposed to just a reflexive stimulus response model. It's not passively pushed around by things in the environment, and it's not pushed around by isolatable parts. It's the whole system deciding. I think that's perfectly valid, reasonable way to describe what's going on there. Okay, now I've already gone too long, too slow. All right. So how do you get from that, from this sort of cybernetic, it's holistic, but it's still a kind of a cybernetic system of these pragmatic couplings, kind of all at one level. How do you get from that to something that's more complicated, that has some internal semantics, things that it can think about? What you need, I think, is, or what happened at least in evolution, is that you got multicellularity, you got the evolution of neurons, and you got the evolution of levels, hierarchies within the system, where one level is looking down at the one below, in a sense, and making sense of the information it's getting from that level all the way to the outside of the organism. And then it's integrating that, and that allows it to think about things that it couldn't think about before. And it allows it, or it makes it valuable to have cognitive systems that enable it to plan over longer timeframes, predict the world over longer timeframes, and so on. So to me, that seems like a natural evolutionary progression, starting with the invention of neurons, to simple nerve nets, which really probably originated to coordinate movement of multicellular bodies. That's the problem that neurons probably were invented for, but quickly you can see how they can get linked to sensory information and then coordinate adaptive responses in response to what's happening. So even in a simple thing like a nematode, for example, you have the beginnings of a brain, a centralized brain up the right-hand side there, which can take information from these are sensory touch neurons shown on the bottom, which can coordinate a very simple selection of an action from a repertoire. So the repertoire of actions that nematodes have is very small. They can move forwards, they can move backwards, they can wiggle their head around, and they do a few other things. That's basically it. So the problem that the organism faces is now that there's multiple things out in the world that it either likes or doesn't like. So it doesn't like being touched, and there's various chemicals that it can smell, some which it likes, some which it doesn't. So what it has to do is integrate those signals and then send them to some command neurons that control what's going on in the outside, what actions it takes. And it's these sort of middle bits, these interneurons, which are the bits that are doing the cognition in the system now for the nervous system. And really the whole story of the rest of evolution of multicellular animals is the expansion of the red bits. You still have grounding from the sensory world, and you still have grounding in terms of action. You've just got lots and lots more levels of processing and control. So that relates in a way to this idea of cognitive depth. These worms are doing some simple cognition, but they're not thinking about much because they don't have much to think about, just things that touch them, things that they can smell, so chemicals they are directly perceiving. They inhabit the here and now. So Mike would say their cognitive light cone is tiny. But the evolution of vision and hearing, these distant senses, meant that the organism, first of all, is indirectly perceiving things, not perceiving the objects directly, it's perceiving light bouncing off them or vibrations of the air or the water. So it has to do some inference about what's out in the world, which is what it cares about, right? It doesn't care about photons hitting its retina, it cares about what they're bouncing off of in the world. That takes some processing. So this idea of direct perception just doesn't hold. It doesn't fit the job description for what visual vision has to do for the organism. but also it means that they can see things coming from a mile away. It pays to be able to think about things that are a mile away in time. And so you get that sort of sophistication. If you think about a hierarchy, which I think is necessary for this, if you just had this sort of linear system on the left there, information would just be lost because these are noisy channels. All you would do is lose information. But that's not what happens. Instead, you have this kind of a system on the right where you always get some kind of convergence, right? Each layer is pulling information from multiple sources. That allows it to extract higher order pattern information that the neurons down below don't know about, right? These neurons, each of those neurons on the bottom level don't know what the activity of its neighbors are. But as you go up, they do know. That's the information that they carry. So it's not just a coarse graining, which sounds like you're losing information along the way. It's a creation of different types of information that's most relevant to the goals of the organism and the needs of the organism. What's out in the world? What should I do about it? And we see that in the visual system, starting in the retina, for example, with comparisons between neighboring photoreceptor signals that allow us to pull out contrast or color and so on. And that continues on through the visual system, where we're ultimately extracting information and representing information about things like edges and objects and types of objects like faces and so on. And of course, what I haven't shown is the downward arrows here doing the predictive inference, which are clearly crucial. So what we get ultimately is these internalized representations. And that's a term that's used in neuroscience and psychology, cognitive science, computer science. It's very muddled. But what I mean here is that you've got some neural patterns of activity within the brain at various levels that mean different things to the organism. So first of all, they're about something. They're about something in the world, and that's an uncontroversial statement of physical correlation, basically. But also, they're grounded by experience in this web of context. Right? So they're grounded by what we know about the world. The organism is not naively encountering things. It has a web of knowledge. It has a bunch of schemas. It knows things about stuff in the world. So it doesn't just detect an object and discriminate it from the ground. It recognizes what that is, and that involves relating it back to this store of knowledge that it has built up. Some of that may be evolutionary. A lot of it is learned through individual experience. And even though they're decoupled from action, obligate action, those representations are still used to inform action. So they're for something as well as being about something in the world. And again, I think that's a naturalized way to think about these that is a non-mysterious kind of description of what representations are. In humans, of course, we get these sort of expansion of association areas, which means we can think about more and more abstract things. We can develop knowledge of categories of things, types of objects, relations between them, types of relations between objects. We can do analogies, and that's what actually a lot of our complex thinking entails, is recognizing something as an example or an instance of some principle that we understand. Thereby we can know what to do, even in novel situations. So you get a kind of a mapping from basic percepts to more abstract concepts as you go this way through the sensory cortices. And at the same time, you get a kind of a mapping from very basic motor actions to short-term plans to longer-term goals. So you have this sort of nested hierarchy of action control that relates to this nested hierarchy of concepts percepts and concepts. So ultimately, our behavioral control, both at any moment and in terms of the management of any organism's behavior over time, it really is a management problem, involves seeing things, linking them to known knowledge, especially of causal relations and affordances in the world, and then taking action. So you can think about these sort of different internal loops that are happening. And of course, there's very well-known neuroscience now that underlies a lot of these different elements. That doesn't mean it's just the neural circuits doing it. It means it's the organism using the neural circuits to do these things. At least that's the way that I see it. There's some interesting questions there about what an organism can perceive, what it can infer about the world. It's limited in how much it can infer based on how many levels of the hierarchy it has, how many things it can compare across. What can it be thinking about? which of course is relevant to questions that I know you're all interested in, like what can it care about, which I think is what matters to it in an adaptive sense. What things can it do something about? There's no point wasting energy thinking about stuff it can't act on, right? Evolution will, that's the payoff for all that expensive neural machinery. Evolution is only going to reinforce those, the investment in neural machinery if it pays off in some adaptive action. And then what is that repertoire of possible actions? Again, that's quite limited in many organisms. In humans, we have an almost open-ended repertoire of possible actions, which raises its own problems in that we have ostensibly an infinite search space to look across whenever we encounter a new problem. As it happens, we don't, of course, actually do that. And then there's, of course, the questions of the length of time that it can predict and plan over and exert sustained control over. So it's not just a matter of doing a behavior right now, taking an action right now. In some cases, an organism has a plan. To enact that plan, it's not sufficient to just say, I have a plan. That plan, having the plan, has to be a constraint that continues to constrain its behavior through time. And that's not, that's not a negative sense of the word constraint. It's an enabling constraint that enables a long-term goal to be held. Clearly, sorry, I just want to check, Mike, how long have I got?
You still got about 20, 25.
Oh, great. Okay. Okay, so one of the key points here that I mentioned as one of these sort of criteria for agency is historicity. So the system carries a memory of previous actions in the world, previous perceptions and so on, that in creatures with nervous systems are embodied in changes in synaptic connectivity, synaptic weights, other sorts of plastic changes in the organism that basically constitute a memory of some kind. And they set a new criteria for action. So knowing that X happened the last time in terms of reinforcement learning, and it turned out well, reinforces that as one of the options in your search space the next time you encounter something, right? That's how habitual actions emerge eventually. So it's recalibrating the value attached to various mental states. So if you care about something, it's resetting the desired goals or the desired actions and so on. And that happens across evolution, where there's a lot of just sort of pragmatic meaning embedded in the configuration of the organisms that's there because it has been adaptive over the environments that the ancestors of that organism has encountered through time. But it also happens across individual life. And of course, it happens much faster through individual life, where we have this learned meaning and value. One of the key points from that is that if we're only thinking of this problem of action and free will in terms of the instantaneous state of an organism, we're just missing huge amounts of the causation in the system, right? Living things are historical. That's by definition, right? They're persisting through time. And that causation, that historicity, is the key fact if we want to understand not just what are the mechanisms that enable an organism to do X right now, but why it's configured that way. And we can't really think in instantaneous terms and get a full picture of what's happening. In fact, that throws out what we really want to explain and understand. Okay, so just a quick point on intelligence, especially in relation to artificial intelligence. My view is that a lot of the sort of artificial intelligence systems that we have, things that play chess or Go or tell you the next, complete a sentence with a plausible word, for example, are not intelligent in the sense that we think of. Intelligence in organisms is about adaptive behavior, right? It's cashed out in appropriate behavior that fosters persistence through time. So intelligent is as intelligent does, basically. And you can think about cognition as emerging to better control behavior. And I know that seems obvious, right? But it's not actually the way that many people in cognitive science think about cognition necessarily. But if you think about it as an elaboration of a control system, where these more sophisticated cognitive systems allow you better control over longer timeframes, over greater numbers of possibly conflicting or competing goals, and so on, then I think, for me at least, that's a framework that's consistent and allows us to understand how you get to this sort of abstract reasoning that we have and what's the value of it. And you may at some point think, well, eventually we became so capable of open-ended cognition that we broke free from that, right? For us, it's not just a control system anymore. And I think that's perfectly valid. I think that's right, actually. But I also think if you want to understand where that came from, the idea of it as a control system is really useful because it grounds everything else. Now, I've been talking about the meaning of neural states or biochemical states as having some causal power in the system, and I completely sidestepped this problem of physical determinism. If the physical world is purely deterministic, what does it matter what some neural state means? Right? The molecules in these neurons are just going to do what they're going to do anyway. And the next state will just be determined by the way the physical forces play out. The Schrödinger equation, whatever it is, will just be deterministic. Well, it isn't deterministic. So even physics says it isn't deterministic. Actually, the Schrödinger equation, which is the equation that's used to figure out the relationships of all the quantum fields and particles and so on and what their next state will be, only gives you, deterministically speaking, a set of probabilities for sort of, the probability density function for the next state. When you need to actually look at what the system's going to be like, it collapses to one of those in a random way, as far as we know. So the way that systems evolve through time is not deterministic from the basic level of physics, and that opens the door for the higher level organization of the system to have some causal power in a way that's some people seem to think violates the underlying laws of physics, pushes the molecules around. It just constrains them. It's like water in a pipe flowing the way the pipe goes. It's not magic. I don't know why people have such a hard time with this, but basically the physics, the current state of the system and the laws of physics don't determine the next state. They underdetermine it, which means that the system itself, some organizational properties, can have some causal power, some top-down causation that's real, without being spooky. And actually, George Ellis has some really nice examples of that from computer science. That's what computer programs do. They constrain the way electrons move around in your computer in a totally non-mysterious, commonplace kind of a way, right? Based on the thoughts of the programmer. It's not magic. I'm going to skip some of the physics stuff, but we can come back to it if you want. So yeah, George Ellis and Helen Stewart both really nicely outline how this indeterminacy creates some causal slack in the system. So people in the free will debates often say, well, look, either the physics is deterministic, in which case you have no free will, or there's some randomness, in which case the things that happen are determined by the randomness at the low level, in which case you have no free will. And actually going back as far as Epicurus, in the ancient Greek philosopher, he realized that that indeterminacy at the low level is required and enables some macroscopic causation to happen, right? And enables free will to exist. It's not that the random things decide what happens, it's that they underdetermine what happens. So the randomness is not a positive thing that enters the system at some stage. It's a negative. It's a lack of constraint. And then the organism, the system can be arranged and organized in functional ways. And natural selection does the design work to select those functionalities of the system. Now, one way to think about that, to say, okay, well, yeah, but I still think all the causation's happening at the lowest levels. I still think it's any particular macroscopic state, say some pattern of neural activity that represents a face out in the world, will nevertheless be instantiated in some pattern of low-level details, and it's those low-level details at any moment that are going to drive what happens. Now, one way to think about causation, our typical way that we do, commonplace way, is in a counterfactual sense. So if you want to say, well, X happened because of A, well, then usually that implies if A had not been the case, X would not have happened, right? That's the counterfactual power there to say that it's A that is the determining factor. Well, when you look at neural patterns of activity at the very low level, so some population of neurons, and you get all the low-level details, most of the time they don't matter. Right? They're filtered out as the nervous system goes from, takes information from one neuron to the next. or from one population to the next. What matters is the pattern of activity, and there may be lots of microstates that all correspond to a given macro state in any part of the nervous system. It's the macrostates that have causal power in the system, and they have causal power because they mean something. So, for example, you may have some population of neurons that's monitoring another population, and I like that formulation. I think there's a traditional way of thinking about neural activity where we have a neuron that fires and it causes the next one to fire, right? It's a feed-forward driving kind of a thing, as opposed to what's really happening, which is a set of neurons that's looking at its inputs and it's inferring something about the state of the world or the state of itself from that. So you may have lots of different microstates here. You could change them and nothing different would happen. They don't have counterfactual power. What has counterfactual power is when the microstate moves from meaning pattern A to meaning pattern B as inferred or interpreted by this population that's looking at it. So this pattern here might mean there's a stick on the path, and this pattern might mean there's a snake on the path, right? But there can be loads and loads of instantiations of those things, which it's the pattern that makes the difference. So and we can see this, there's tons of beautiful work coming out in neuroscience these days, looking at population encoding, these neural manifolds where you have these different sort of subspaces of population activity, where you clearly, this sort of distinction of meaning is neurally instantiated, again, without any kind of spookiness. So I would say, rather than taking this eliminative reductionist approach where we reduce psychological states to neural states, and where you can keep going and ultimately say it's just the physics that's driving everything, I would say exactly the opposite is the case, that actually those neural patterns and mental states and so on only have causal power in the system by virtue of their meaning to the organism. At organism level relevance, things in the world, right? Not photons hitting your retina. So for me, that sort of gets around this issue of the very, very troublesome issue of mental causation, the sort of classic problem of top-down causation, where the top is something mental and the bottom is something physical, right? And so many people would say, well, how could having a thought, how could the content of a thought have causal power in a physical system? What does that even mean? Thoughts are immaterial. How could they affect physical stuff? Well, thoughts are not immaterial. They're patterns of neural activity. And well, if you say that, then people say, well, yeah, see, I told you, they're just patterns of neural activity. It's just neuroscience. No, they're patterns of neural activity that mean something to the organism. And it's the meaning that drives the mechanism. I think that's really key. And for me, it gets around the problem. I kind of call that cognitive realism, although that's just a made up term because I didn't have any better term to think about that. Okay. Let me just say there are lots of implications, I think, for thinking about artificial intelligence and artificial life with respect to this. Nature has given us an existence proof that cognitive things can be made from physical systems without a vital force or any kind of disembodied immaterial soul. However, it's shown us that the architecture to do that may require an embodied self that interacts with the world, that has some causal experience with the world. It's not just getting lots of data the way large language models do, where it's building up patterns of statistical correlations. It can't tell correlation from causation because it can't do anything, right? But an embodied self may be able to do that, may be able to learn causal regularities, but it may have to have some kind of master utility function on which to ground some normativity for itself that would actually give it the ability to behave and learn and reasons to care and allow it to build up more complex things to care about. But it would need some real degrees of freedom as well in that system. I don't think you'd get that in a fully deterministic system. I think there has to be some wiggle room. So for me, being intelligent means acting intelligently. And I think I don't see any reason why you couldn't build a system like that. I think there's lots of reasons why we shouldn't build a system like that. That's a different question. Okay, I think I'm gonna stop. I have a bunch of other sort of things about selves and different types and levels of selves, which we could talk about, some other time, but maybe I'd better stop there, and yeah, the free will stuff is a whole other thing. Anyway, I'll just leave that there and be a little cheeky. Thanks very much.
Amazing, thank you so much. That follows up so well with what Anil started. I have so many questions. I'll just pick one for now, because it's relevant to what we wrote as what we are thinking of as Bodhisattva vow, and possibility for infinite capacities of learning or infinite knowledge, that kind of crazy stuff. So you mentioned at some point about the nematodes, the Umwelt and so on, right? They're not thinking that much. Humans also have their own limits, and there might be limits to which we can, or any agent can care about stuff. But how about things like discovery? Is there a way? I think that's when you mentioned about AI performing very well at chess or Go, adaptive stuff. All of this cognitive power, could it be made unbounded by evolutionary means? So even forget about design and everything. Could it be emergently made so that it discovers or wants to discover forever in a sort of second order, third order derivative way?
Yeah, I think it has been. Right? I mean, I think we're an example of that. Or, well, we're the example of that. The only one that we know of so far. I kind of just referred to this idea of transcendence from the biology. These systems got complicated enough to allow us to develop, to think about abstract concepts in a limitless way, I think. And the only limit probably would be what an individual human being can learn about in its own lifetime. But that limit has been transcended by culture and language. So, I didn't talk about the post-biological evolution of humans as a species, as a culture. And I think, people sometimes say, oh, the brain is so complicated. It's obviously so complicated it can't understand itself. How could it? Well, we're not just one brain trying to understand it. We're all this collective, right? So we can think about incredibly abstract things in mathematics and all the sort of scientific things and cultural things that we do think about. So for me, that transcendence has happened, right? The singularity has occurred. We're it. It's interesting to ask what it is that enabled that, because that cognitive architecture was there for millions of years, and in Homo species for hundreds of thousands of years, with very little change in behavior as far as anthropology can tell us. So at some point, some cultural sort of revolution happened that enabled cultural evolution to happen in a way that really became unbounded, I think.
Hi, thanks for this talk. This was really, really cool. I also have a lot of questions, and I'm going to ask one. Actually, follows really nicely from Olaf's and I guess from what you just mentioned about the evolution of culture. So I'm wondering if you take on, so I can understand the idea that organisms basically develop behaviors based on what they care about and the extraction of meaning from the world and from its own experience. But how does one learn what to care about? Right. So in the sense that, one thing is, I guess, easier to imagine exploration, you face plant or gain stuff, then you learn a thing or two. But also, what about the role of affect and aesthetics and ethics, right? We make choices about what we care about, often not based on obvious pragmatic values, but, music or, I don't know, beauty, right? Other things.
Yeah. Okay. So there's two levels to that question. One is I guess, how do animals learn what to care about, and then for us, how does that sort of evolved structure enable us to think about things that don't have obvious immediate adaptive value and so on. I think the second one is Yeah, it gets, it gets back to this idea of transcendence, right? That we can think about things that aren't of immediate survival importance. Part of that is just the luxury that we are really good at surviving collectively, right? So we're the hyper-social species. Our intelligence has given us the power to manipulate the environment and control it over a long time frame, which just partly means we don't have to be constantly in a struggle for immediate existence, right? We're not scrabbling around for food every hour of the day, in the way that even close primate relatives spend a lot of their time doing. So partly I think that's the luxury of how far we've come in that cultural evolution. I don't know if that's a satisfying answer, but it's probably as good as I'm going to give. I think that on the other front, the questions of how organisms learn what to care about, there's multiple levels, right? There's data that it's getting, a picture it's building up of things in the world. And then there's a kind of an unsupervised learning, I think, about regularities in the world. So if things are reinforced by occurring again and again, those will be learned and remembered. Whereas there are active systems for forgetting things that are not regular, right? That's not just not learning, it's unlearning things. So I think there's a very active throttle point of efficiency there, right? You don't want to learn about stuff that isn't reliable. And in fact, many artificial systems overfit data precisely because they don't have that kind of efficiency throttle within there. So we're unlearning things a lot. And then of course there's reinforcement learning, which is, if something turns out well, there are signals. And again, they manifest as affect. You can think about them as control signals in a cybernetic sense or a computational sense. Why they feel the way they do is a whole other question. But clearly there are basic fundamental signals that Mark Soames may talk about that act as both homeostatic signals in an immediate sense, as behavioral drive signals, and also as reinforcement learning signals. And you can track the evolution of those things from immediate sort of signals of state, like dopamine does in nematodes, for example, to reinforcement learning signals that dopamine has in humans. So I think all of those things are happening all the time. And for organisms, the key thing is, what do I learn that helps me adapt in the world? And those are going to be the things that are most predictive of what's out in the world in a dynamic environment. And that depends on the historical survey that the organism has had through its own experience, I think.
I try not to say this after talks, but great talk, man.
Thank you.
Really fun. And I join these. We're going to have a lot of questions for you.
Yeah.
But I may already know the answer. I'd be curious just to hear you enunciate it. There's this very strong through line of time in the way you're thinking about the world. And one of the things all of us are obviously thinking about is the dissolution of self in some kind of a temporal sense.
Yeah.
It sounds to me like you mean time to have to do with persistence long enough to. So I guess my question to you is, it's an easy one. What is time? Yeah,
that's super. Thanks a lot. Yeah, super easy. So I think I take a different view from what I understand, and I'll have to ask you guys about this, in terms of the dissolution of self, or the idea that the self is an illusion because it's not a constant substance or an object. And I just don't see it that way. I see the self as a processual sort of thing, a set of processes that are persisting through time, and it's the continuity through time that is the selfhood. And in fact, I mean, one of the ideas, I don't know if you can see this. So in the free will debate, there's this idea that you're only free if you're completely unaffected by any prior cause whatsoever. And that sounds great until you think about it for a second, because it's really incoherent, right? Because actually you disappear in that scenario. Right? The only thing that makes you is this set of constraints through time, constraining your biology, your psychology, your behavior, personality, and character through time. So, there's this sort of notion that maybe we should want to be able to want what we want and not just do what we want. But in fact, again, there's an infinite regress here. Okay, so you can want what you want. What do you want? Why do you want that? It's just, they're still going to have reasons, right? So doing things for reasons is what an agent really is. So this on the left panels of this cartoon are supposed to sort of tease that out and say, oh yeah, it's great, I'm completely free, no constraints, I can do what I want. But wait, why should I want anything? There's no reason to want anything. And once you do that, you realize the self just it really does disappear in that scenario because it's not continuous through time. Whereas the ones who have goals and accumulated knowledge and so on have reasons and can act for those reasons. And those are constraints, right? They are. But there's nothing to the self but constraints. And that persists through time. So I see the self, the physical instantiation right now, as what I call a momentary avatar of a self that persists through time. So it's a different view of the self, but I don't see the self as disappearing in that view. Now there's a whole other sort of discussion we can have about time, which gets into the physics and stuff, but I think that probably might take too long. So maybe we can pick that up later on.
I've got a.
Oh, sorry, I just noticed there was a question from Dennis, I think.
Go ahead.
I don't know if it's in the.
Do that one.
Oh yeah. Okay. So yeah. So Dennis says, I agree that micro-indeterminacy, whether quantal or classical, underdetermines. To this, I think we need to add that once used by the agent, it is no longer random. Does this also feature in your account? Okay, so actually I should have mentioned Dennis there too, because I really like that view of harnessing stochasticity. And in fact, I think that's what allows life and defines life. Whether it becomes no longer random, I think that underlying underdetermination enables macroscopic patterns that mean something to have causal power. And that's not random, right? That's selected through time. So in that sense, I would say it's no longer random. I don't think that those things push the randomness around or decide what the randomness will do. I think that's another misconceived formulation of how free will affects things, that it's pushing all the way back down and making the little things do something. I don't think that's right. I think it's constraining the organization and the flow of things through the organization. So I don't know if that answers the question fully, but I hope so.
I've got sort of a weird, I guess, kind of a meta-scientific question, which is, and I assume you get this too, and I'm curious what you do, what you say to people. So I get a lot of emails from people who they read Dennett or Sapolsky or something else, and they start thinking about this free will stuff, and they become completely destabilized, right? So like literally in their life, they just or they they read my paper that you're made of cells, and so, oh my God, I'm nothing but a pile of cells, and that's it. Like they don't know what to do next. Do you encounter that, and do you have any tools for getting people out of this vortex?
Yeah, I do. It's interesting. So you just mentioned Robert Sapolsky, who has a book coming out just in October as well, which is called Determined: How to Live Without Free Will. So it's the exact opposite view from mine. Yeah. And I've just finished reading it myself. And so he takes the view that neuroscience is showing us that it's the brain that's making decisions, not you, right? So I take the opposite view, right? I'm saying, okay, well, yeah, we understand the neuroscience of decision making. That is how the organism makes decisions with those bits of its brain, not in a collective non-magic sense, not the organism as a homunculus. It's the system making decisions, and the system happens to be an organism. But he also leans heavily into the biological fatalism, the idea that even if the organism is doing it, it's constrained by all of its history. And there's two ways to see that. One is this problem. It's like, okay, what do you want? Something completely unconstrained? That wouldn't be a thing. It wouldn't be alive. It would never have evolved, right? But also where he sees determinants, I see influences. So genes, for example, influence our behavior, but not completely. They don't determine it. Our innate predispositions influence our behavior, but they don't determine it on a moment-to-moment basis. And I think instead you can think of this kind of a view where he would also say our experiences determine what we're doing, as if at any moment they're completely inflicted upon us, right? So they're not anything that we do. They're just things happening to us that we have no control over. So if at any moment you have no control, then over your whole life you had no control. And I think that's wrong. It assumes that the question it's trying to answer. And in fact, if through your own life you're making choices and you're selecting your experiences and your environments, and you're making decisions that include things like long-term policies and projects and commitments that constrain your future behavior and sustain it, then I think you are, in a sense, you have had some hand in the way that you're configured right now. So I think that that's just a wrong view, frankly. But to get to the sort of existential questions, so it's really difficult to know how to live if you really think there's no free will and you really think you're not making actions. And so Sapolsky goes into this, and the sort of second half of his book is all about that. And a lot of it is about the legal system and so on. I don't know how those people go about their daily lives, frankly. It just is mind-boggling to me how you could really, really feel that you're not in control of anything and yet spend all your time making choices, thinking about other people's choices and their reasons for doing things and your long-term goals. It's completely the bedrock phenomenology of our experience. So I have no clue how people can come to terms with the idea that that's all an illusion and it's just neural machinery chugging away or just physics.
Because the weird thing that happens is it's a self-fulfilling prophecy. Once you start down that road, people, then this is just what I observe, they often get depressed to the point where they are no longer doing all that stuff.
Yeah.
And the less you do it, you say, wow, it's true. I really haven't done anything.
Yeah.
And then it just, and it just gets worse and worse.
Well, I mean, I think one thing that is a sort of more practical is to realize that what we call our free will is not some abstract metaphysical property. It's an evolved biological capacity, and it can be impaired, right? I mean, it's impaired if you take drugs. It's impaired if you get a head injury. It's impaired if you're under stress or hungry. It's kind of crap in babies, right? Babies aren't really don't have a lot of behavioral control, right? So it's a capacity that evolves through time, both evolutionarily and ontologically. And it's one that is subject to, conditions, both sort of biochemical neural conditions as well as conditions that you're experiencing. So, we all have, I think, a drive to maximize that feeling of agency. And there's psychological terms for that drive. It's why I don't know if you experience this, I really do strongly. There's a thing called demand avoidance, where if you were going to do something and then someone asks you to do it, you're like, no, well, I don't want to do it now. You're stripping me of my agency. You're telling me I was just going to do it. And I think actually in a fundamental sense, you can formalize that even in very simple systems, that what they're doing a lot of the time, a lot of what's guiding their behavior is actually trying to maximize their own causal power through time. And so there's a whole sort of, area of research about that, and that can apply to artificial systems as well. I forgot where we started with that. Sorry. I shouldn't be allowed to just keep rambling. Sorry.
So to pick up on maybe a couple of different things from this, I like this idea. You said there's a cultural moment that allowed us to get to this singularity. How have we defined this moment? And it's kind of interesting then to pick up on, and then people are encountering these ideas and having, and it's causing challenges. And then I guess part of the reason for us getting together in this formation is there's some compatibility or crossover with Buddhist thought, with these more formal Western approaches. So I'm kind of wondering if you have thoughts about like the next cultural moment or the next Overton window or the next like narrative topology, or kind of however you define it, that is coming next or needs to come next for this kind of these ideas to advance.
Yeah, it does feel like we're having a moment, which is partly why I thought it was a good time to write this book. Just in my own, in the neuroscience field, there's a lot of sort of neuroscientists coming out like Robert Sapolsky and many others who are advancing this sort of neural reductionist kind of view, which to me strips away the humanity. Right? I mean, it strips away agency altogether, really. And I think that's a dangerous view, societally speaking. I don't know how much traction it has. It's hard to know, even amongst neuroscientists, how many of them think along those lines. I think many neuroscientists just don't like to think about things like free will. So they can't see how to resolve it, but they also don't just accept that we don't have it. And I don't know within the general public, what those feelings are like either. But my own feeling is that the sort of the rise of AI, if you will, is furthering those existential crises. Right? So it's causing people to think, well, shit, maybe my thinking is nothing but that sort of thing. And I think that's only going to continue over the next few years. So it does feel like we're in a moment where there is some sort of existential crisis happening about what we are, what human beings are, what other agents, other organisms are, what enables them to be like that, that we can naturalize without having to rely on dualist, vitalist kinds of notions, because that's another thing that I think scares a lot of scientists off. When you start talking about things like purpose and meaning and value, the hackles go up. You know, a lot of scientists are allergic to those terms. They don't sound very scientific. They're not quantifiable and localizable and so on. And you know, part of the project of this book was to naturalize those and say, no, that we can talk about those in perfectly scientific ways without any woo. And without any danger that we're going to polarize the discussion into hyper-materialism or, you know, airy-fairy mysticism. And I think it's those mystical connotations push some people further towards the materialism because they think that's the only alternative. And then it reifies this polarization that happened. Now that's on a scientific discussion level. I don't have a good sense, to be honest, in the wider societal sphere of where those things are, but it certainly feels like there's a lot of interest, and I think the AI stuff is probably driving that or provoking it. Yeah.
A question that Lisa also might want to chime in on. So I was really struck, Mike, by when you were talking about people being exposed to Sapolsky and it sapping their will to live, essentially a destabilization of our internalized representation of what a self is. Our model essentially says that having a supple and contextual sense of self, which is a different form of that deconstruction of the self, creates affordances. But I think what you're talking about also shows that there's an off-ramp that people can fall into of that destabilization, maybe absent some notion of care.
Yeah.
That, you know,
that
because it seems like the real difference of which way on the off-ramp do you take is, does your sense of care transcend your biological mechanisms?
Yeah.
So, you know, and how might we create systems that would launch people more in that direction at the same time that we are trying to destabilize this very central illusion?
Yeah, I think I agree with that. I think there's one way to say, you know, if everything's comes down to physics, there is no reason to care, right? There's no, you know, in that physical predeterministic universe, nothing matters literally to anything because there could be nothing that could care about anything because there are no choices or possibilities open. There's only one future. And in fact, I go further than most of the people who challenge that sort of compatibilist view by saying there would be no agents in that universe that you could be talking about as whether they have free will or not, right? They just wouldn't arise. The whole dynamic that gives rise to them wouldn't be there. So I'm very sympathetic to the idea of this model of care, and I look forward to learning more about it from all of you. But I think that's exactly right, that's the distinguishing feature in whether you fall into a nihilistic despair or whether you have some kind of maybe more enlightened moment that actually allows you to see, well, yeah, I would say the illusion of self is not that the self doesn't exist, it's that it isn't what we thought it was. So if you're using illusion in that sense, then I'm happy with it. But that sort of continuity through time is a perspective that I think can be a growth allowing perspective. And certainly the idea of recognizing the agency of other organisms is one that should, I think, promote a greater sphere of care than we have as a species so far exercised.
Yeah, sorry to grab the mic again. Thanks, Bill. Yeah, actually, as I was listening to this interaction, I was also thinking about, so this book is coming out in a particular historical moment, and I was thinking, so perhaps we can think about it in a continuum of, let's say, I just made it up right now, like pathologies of free will, right? There's one pathology of free will that would be, you know, exercise as much a gentle control as possible, bend the world to your will, and this way, you know, you exist, right? you do stuff, you affect things, like amazing, let the world burn kind of thing. Okay, the other pathology is this extreme nihilism, right? So, but that other pathology can also be protective, right? And that's why we have such strong, let's say, various forms of conservative movements, right? No, we do not change things because that's the way they are. You know, this is my place because I'm a woman, right? There's a lot of these things. This is predetermined. This is, okay, predetermined by biology or God or whatever you have. So those pathologies. And so the question is, okay, so how in this social cultural moment of our interactive relationship with matter, with the ideas of neuroscience, with the ideas of neuroenchantment also, we are sort of obsessed with the idea that if we can explain things through neurons, that will help us somehow make sense of things in our social moment.
Yeah.
So what would be your take on how we can kind of navigate between those pathologies through trying to understand, let's say, things like free will in a, as you're saying, non-spooky way?
I guess, I mean, thanks for the question. And those are great thoughts. A lot of them are above my pay grade as a neuroscientist. I think there's a lot of sort of sociological, collective, psychological, political questions that are informed by what we think about free will. I don't have mature opinions on them, and even if I did, I'm not sure they'd be informed opinions. I mean, as I think about them, and hopefully as we get to talk about them, I'm sure I will have some opinions, but I don't know what they are yet. I think what I wanted to do was the neuroenchantment thing drives me bananas. And there's a term for it that we use, which is neurobollocks. Right? So there's a lot of neurobollocks out there that we see in the newspapers, for example, where you get this story of, you know, oh, you were afraid of something. Well, that's because your amygdala was activated. And like, that's an explanation. First of all, like, it's right, it's not right. But secondly, like, it's an explanation of things. And all you've done is just shift the level of what needs explaining to another level. Why does that constitute being afraid? Why does it feel like something? How does that motivate behavior? And of course, you can go down the how does it motivate behavior thing, and you get these neural circuits and say, look, it goes like this, that's all it is. There you go. I've explained it. And we're enchanted, right? So it's like, ooh, look, there's an fMRI picture, the little flowy blobs in the thing. Well, it must be right. And it's got a scienciness and a truthiness to it, but it's eliminative in the sense that it eliminates the causal power of cognitive states, of beliefs and desires, in this case, emotions. And part of what I wanted to do in this sort of cognitive realism, as I've termed it, was say, no, those things are real. The neural states just happen to be the instantiation of it at any given moment. That's just the machinery, the means by which those things happen. So if that view can undo a little bit of that, what I take to be a really naive neural reductionism, which is prevalent both in neuroscience itself, but very much in the public-facing sort of aspects of neuroscience, then hopefully that will have been a service. And what comes from that in terms of the wider questions that you're asking, I don't know. Like I said, we'll have to ask people who are more qualified, like all of you.
Thanks. I'd like to circle back to the self for a second and ask, so I'm fairly confident that in your model, you're not following a sort of classical version of the problem of free will, which basically has to do with punishment and reward. So, you know, there's got to be a decider who decided to engage in an action, and that decider is going to be worthy of punishment or reward, basically a theological issue. That's a big part of the history of free will in the West.
Yeah.
And where it's mostly, interestingly, not such a big deal in India, but quite important in the West. On that account, then there's like a decider that can be specified in each moment historically, such that punishment or reward is required. I'm guessing in your model, there is not a decider. There's nothing you can specify in each moment that is the decider, like, I don't know, a particular region or a network or whatever that's doing the deciding. So just to clarify, I'm guessing that there's not that kind of decider that's a specific chooser of making the choice, which then raises the question, what is but there is some sense of like continuity, or persistence is the term you've been using. And so then I'm just wondering what persists.
Yeah, great question. So yes, I don't think I don't think it's right to localize deciders as, for example, your amygdala being activated or whatever. It may be that your amygdala was activated when you saw a snake and so on, right? And that was part of what informed your decision making. But if you're a herpetologist, seeing a snake may not be particularly fearful experience. So I don't think you can simplify and reduce those things. So for me, that's one point, is that if there's a decider, it's the whole organism. But I think the key thing that you touched on there that we mentioned a little bit earlier is this idea of the instantaneous decider. That's not a right thing to think about, I think, because you don't get a full explanation from the current physical state of the system, the way that it's organized, because you miss all of the historicity that says, why is it organized that way, as well as what the organism is engaged in, right? Which is not just being an instantaneous thing, adapting or reacting to sudden stimuli right now, and then this, and then that. It's not how we live. It's not how many organisms live. They're doing things over sustained periods of time. They're organizing, they're managing their behavioral repertoires over time in a way that constrains and gives context to action selection at any given moment within that window. And you can, this is the picture of doing that over a lifetime. And you could say that a person is responsible for where they've ended up along here through the exercise of their agency through time, as much as saying you're responsible for this action right now. Right? So as far as moral and legal responsibility goes, I actually at the start of this book dissociate those from the question of free will, because I think if you consider free will just in terms of moral responsibility, which is where that's the arena that it's normally fought on, it just muddies the waters. For me, the question of moral responsibility is a secondary one. It's super important, and free will is super relevant to it, but it's not the same thing. And a lot of the discussion, I think, Dan Dennett, for example, talks about a kind of free will worth wanting, which is clearly motivated reasoning, right? For how can we protect the idea of moral responsibility in a deterministic world, which is moot in my view. But yeah, when you tie those things up so tightly together, then it becomes really hard to know, to distinguish the different issues. And so what I wanted to do was to pull them apart, and especially by looking in an evolutionary sense, where we're not so concerned with issues of moral and legal responsibility and so on, we get a clearer view of questions like purpose and meaning and value and continuity through time, that can then hopefully ground our discussions of moral responsibility. But for me, what persists is the self persisting, with all of that history, with all of that future-looking aspects to it at any given moment and through time as well. So if you want to say who's deciding, it's that self that's extended through time, I think, if that's not too vague a way to put it. And maybe we'll have to discuss this a lot more, I think.
I have a question, comment. So I was really struck, this is a great talk, by the cartoon showing that if a person doesn't have any preferences, no history, nothing, the absolute free will doesn't exist because that person doesn't exist, right? And the parallel with Buddhism is pretty striking, right? And in some ways, Buddhism talks about the self is an illusion, but it's actually not quite exactly what it says. It really says self is a construction. It doesn't exist as independent entity, but it's a construction. And that's where, but the mistaking it for a independent entity is where the cause of mental suffering is in the world, in most people, right? So I think, and then this nihilism that can come out of realizing it's a construction, or rather misunderstanding, it's an illusion, doesn't exist, there's no free will whatsoever, that Mike talked about, is indeed in Buddhism is in some ways balanced between this compassion versus wisdom. That wisdom says that we don't exist as everything is a construction, right? Everything's empty, whatnot. But wisdom needs to be balanced. And if you're only wise, they say, I don't have to care. I don't have to help anybody, right? Because nothing really matters. Everything is construction. But in teaching, is always a wisdom combined with compassion. And compassion is the caring that talks about. These two have to exist at the same time, because otherwise things just wouldn't work. Right? So I find it's really fascinating that this talk on neurobiology really reminds me of some of the teaching of Buddhism, and of course of physics as well, where quantum mechanics, the observer effect, where at the most basic level of reality, the observer, which is consciousness, collapses the wave function, right? So this whole circle kind of works both on the Buddhism level and the quantum mechanical level. So I find it really fascinating. So thank you.
Yeah, thanks a lot. Yeah, I mean, I think for me in writing this book and reading, a bunch of stuff, for me, I guess the perspective that I'm showing fits really well with a process philosophy as opposed to a substance philosophy, but also with a relational one, with the idea that actually things don't have properties in and of themselves. There are no private properties that don't manifest in relations with other things. Otherwise, they would be unknown, unknowable, properties, right? They wouldn't be a property. So I'm very sympathetic to the idea, going down all the way down to basic physics, that the properties of things are only relational, right? The properties emerge from the relations as opposed to the other way around. And I would say that very much for human beings as well, in terms of social self and our psychological self, that our psychological self it mainly reflects relations that we have with other people. And so, yeah, I think that for me, it's getting away from a substance object kind of ontology towards a much more processual, relational ontology that feels right from a scientific point of view. And in a sense, it may feel healthier from a psychological, sociological point of view.
Philosophy, quantum physics, and all of these are
yeah.
So this is I've been trying to compose this into a coherent set of thoughts with mixed success. So
Me too.
It's not like fully formed into like a nice question. I guess the two sets of thoughts I did want to say were that one is that your book sounds exciting because and kind of like, to me, so I started doing AI research a long time ago, and I think a long time ago, but one of the things that struck me is that we always think something is mystical or magical, right? When we don't have the capacity to hold it in our mind and understand it. And so I think a lot of the dismissiveness that people have towards these questions actually has to do with people not knowing whether we're at that point in human history or development, right, where we've chunked enough to understand that this isn't like sorcery or mysticism or religion, right? But I guess the other aspect I was thinking about, and I was wondering whether it's in line with your framework, was that if you think about it, there's this paradox with free will where it's almost like the experience of time and the fact that we engage with others is kind of what leads to this idea of falling apart without free will. Like, in a way, it's this idea of, like we say, when, we can't change the past. Like, the way we experience time is linear and we can't exchange the past. And madness lies in becoming obsessed with what could have been because we can't change it, right? But madness, in theory, also lies in thinking that we have no free will, like there are, like, in deciding there are no possibilities going forward.
Yeah, I agree. Sorry, let me see if I had that little bit in here. I did. This is my little bit of physics. So yeah, I think that, so this is a picture of time that comes from work from Lee Smolin on the quantum level and people like Nicolas Gizan on the sort of classical level. And the idea is that the transition between quantum things that are indeterminate and probabilistic and so-called classical realm that's supposedly deterministic is not one of spatial scale and complexity. It's about time. It's the transition from the future, which is open and fuzzy and indefinite, to the past, which is fixed, right? But the present is the moment when things become definite through interaction. And I would say not just through not just through observation, through any physical interaction. I don't think the observer in quantum physics is important.
Right.
I think it's just stuff interacting with each other. So all the jitters that are happening there just get fixed in a moment of interaction, and then that's the past. So that's the slice of time that we inhabit and experience as the present, and it's a thick slice, right? It's not an instant.
Right.
That time has a duration, and this goes back to other sort of process thinkers like Henri Bergson, for example, who did descend into mysticism. Partly the problem why I think sort of process views have a bad name, and Whitehead did too, actually. So yeah, this picture for me just makes a lot more sense. Rather than thinking of the future as fixed, just one pathway that's always going to happen, that just doesn't even fit physics. But also another way of thinking about it is there's these pathways that are open and you choose between them, but the pathways are predefined. And that doesn't make sense either. There's a fuzziness, and it gets fuzzier the further into the future you go. And as it arrives, things get resolved as sort of a just-in-time reality. That's the way I think of it.
Yeah, I mean, I think the thing that came to me is that our idea of madness, like when we define what madness is, right, in psychology, it's a social thing. We say you've become mad when you cannot engage in socially, you cannot engage functionally socially with society, be that like be unable to talk to people, hold a job, like different extents. And so like, I wonder whether this idea of free will, like, I guess like the poorly formed thing is, I don't know how time and free will connect with socialness, but I think inherently the idea of socialness the idea of free will might be indelibly entwined with socialness.
I think it is in lots of ways. I think evolutionarily the idea of responsibility and reciprocity in social interactions is what has enabled us to evolve as the hypersocial species that we are. Right? So I think there's a lot of good evolutionary biological reasons why we hold each other responsible for things. That's just the way game theory plays out. It doesn't have to be anything more than that, right? But I also think that the idea of what defines madness is an interesting one. And I would say it's absolutely a social construct, right? But in this case, it gets to this idea of the potential sort of pathology of coming to this realization that there is no such thing as free will. And it's interesting that some people present that as almost like they're privy to this special knowledge that like all you plebs need to believe in free will, but I know it's an illusion, and there's a smugness to it that comes from certain commentators that I find really kind of off-putting, and that they see the pathology as believing that you can do things, you poor sheeple, whereas I know that that's not true at all. And so there's an interesting there's an interesting parallel there with a sort of a militant atheism, a smug atheism. And I'm an atheist, but hopefully not a smug one. And not coincidentally, it's some of the same people involved. Maybe they're just smug. I don't know if that answered everything, but I'm happy to chat. And we definitely can chat about mental illness and how that's defined, because I have in my another hat I wear is in psychiatric genetics and psychiatric illness. So I'm always happy to chat about that.
Hey, I just wanted to add a meta comment about how you started your question about saying, I have something that feels important, but it's difficult to articulate, after, I guess, almost 4 years of working on this CSAS of the core team. I wanted to really normalize that, because it's an unusually disciplinarily cross-disciplined, or there's an unusual amount of discipline diversity. And then something, Kevin, that you spoke to is this feeling of being over your skis sometime, of like, I don't know if I know enough to be able to comment on this. I think the stuff that we've really found to be magical about this kind of work is embracing that and leaning a little bit into, oh, I'm good. Like, we don't have to have complete knowledge about what we're saying before we offer something for consideration. So I really want to appreciate you doing that. Because if you think about it, like, we're going to have a monk up there and nobody knows everything about everything that's being said, and that willingness to say, well, based on my background, I have these thoughts, but it's not complete, is one of the things that's really moved this work forward. So I just want to make that comment and encourage it.
Thank you. I also just realized that like Professor Levin and you both, like, I apologized at the beginning of both of my questions, and like you reassured me for the first one and you reassured me for the second one. So like, and the whole time I was like, I'm a bad feminist for apologizing, but I'd be a worse feminist for like asking. And so like, what a lovely feminist setting. Okay.
Well, in some senses.
Yes.
Yeah.
One more, but no. I guess my question was about perspective. It sort of connects with what Bill said earlier. I think a few people were hinting at this. So there is self-causality power or some sort of agency empowerment or free will empowerment that can come from interdeterminacy or under determinism, right? So that's one possibility for sure. Is what are other ones? Is it possible that we can get it from perspectives? And what I'm thinking of is, well, if I don't know, the three main perspectives I see when you look at an agent, you can look at it, in a simulation as God from the outside, and a lot of the old science stuff does exactly that. Or you can look at it from the perspective of another agent within the simulation, right? And that's what humans are trying to do. And I guess, it's so the observer that you were mentioning relates to that directly to me. And the third one would be the perspective of the subjective self of that agent itself.
Yeah.
And the science gets very different.
Sure.
Would those kind of perspectives, and another one would be goals, for example, or being more than one, things like that.
Yeah.
So would that also affect?
Yeah,
free
I
will?
think, and there's a ton of stuff in that. I think that the perspectives that we bring to the scientific enterprise are really crucial. And for example, the ideas of process philosophy versus substance philosophy. And the process philosophers had their day, but it was the early sort of 1920s and so on. And then it just fell away. And interestingly, I think it's coming back. So let me give just one example. It's not directly one of the ones you mentioned, but it's a reductive versus a holistic systems view in science. And I think the reductive view has held sway for decades, partly because it's in a sense successful, or at least seems to be productive, in that you can keep doing things. And it was the only game in town. So when we were looking at behavior in animals, a bunch of neurons, we could only record from, 2 neurons in a dish, in a slice, right? Or 1 neuron in an animal, right? Now we can record for tens of thousands of neurons in an awake behaving animal. And now there's a pressure to say, well, okay, actually, you know what? I can look at the whole system right now. What's the system doing? And that moves you away from the reductive view of individual spikes mattering, pushing things along, as opposed to a view of patterns that mean something to the organism. So that gets us back to, I hope, a bridge to the subjectivity, at least insofar as you can describe it in terms of adaptive elements of cognition for an organism. So you can think about the organism having a belief that X is out in the world, having a desire or a goal to do A or B in different circumstances, having some level of confidence to do that. And we have the tools to look at those things and to manipulate them. And what I hope will happen is that rather than reducing all of that high-level stuff to just the mechanisms, we'll realize that in fact the systems view, which is really a process view, gives us a window that can unite the objective material stuff that's happening with the subjective experience, which it's giving rise to, and which in turn is constraining it, right, and informing it and giving it its causal power. So, so those perspectives, I hope, will come back together. And it feels like to me that as that happens, just by necessity, the scientists who now have these systems level tools and have to develop systems level computation and some philosophy around it, whether they know that's what they're doing or not, will fall back on these things like processual philosophy and relational views and so on, in a way that hopefully can bring those things together as opposed to driving them further and further apart. Yeah, I hope that answered that question.
Really? Great.
Thanks.